So in problem 2A, you've bought a lottery ticket and you've won. And by winning, you've been given a choice of one of two prizes. So the first choice is $500,000 today. The second choice is to take $5,000 at the beginning of each month for 10 years. So that will be all the way up until the 119th month, and you'll have $5,000 each month starting at time 0 all the way up to time 119. Now, what is the best option for you to take? Well, if we consider the $500,000 at time 0, initially we might think, well, $5,000 times 120 is $600,000. Therefore, the second option, $600,000 in nominal terms, is better than $500,000 today. Let's go with option 2 because it's more. We can't think that because we need to consider the time value of money. Now, $5,000 at time 1 is not $5,000 at time 0. $5,000 in 119 months is not the same as $5,000 today. So what I need to do is calculate the present value of all of those payments and then compare it to the $500,000. And the way that we would do that is, because this is an annuity, so the cash flows are the same size, they're equally spaced apart. For option 2, we can use the present value of an annuity formula, which is C over I, outside of 1 minus 1 over 1 plus I to the n. And because the first payment occurs at time 0, it's an annuity due, so I need to adjust it by 1 plus I. Now, in this case, the cash flows are 5,000. N is the number of payments. Now, because the payments start at 0, the 120th payment will be at 119, but there are still 120 payments. And the interest rate is 5% per annum compounded monthly. So here, this is an opportunity cost. So what we're saying is, if we took the lump sum today, we're confident that we could earn 5% per annum compounded monthly. So therefore, that becomes the relevant opportunity cost. Now, because it's compounded monthly, it'll be 0.05 divided by 12. And I need to make sure that the frequency of my interest rate, a monthly interest rate, corresponds with the frequency of payments, which are monthly. Okay. Now we can put the information into the formula. So the PV will equal 5,000 over 0.05 over 12, outside of 1 minus 1 over 1 plus 0.05 over 12 to the power of 120 times 1 plus 0.05 over 12. And that gives me 473,370.95. So would you take 473,370.95 or the 500,000? We can compare these now because we've calculated the second option as a present value, which gives us the value of that alternative at time 0. So what we would say is, therefore, take the lump sum of 500,000 rather than the monthly option. And the reason for that is 500,000 is greater than the present value of the monthly option.